Hey guys, Internet Dude here. Hey, if you own a Jeep, you would realize that it's going to break fairly often. um, I had my truck parked for about 4 or 5 months over the winter. I didn't drive it at all, and I recently got it out and started driving it again, and I noticed it wasn't running quite right from the first startup. It was running kind of rough, and you could smell the exhaust was rich. So I just want to show you some diagnostics I'm going to do to try and fix that issue, and it could apply to other owners. So my Jeep Comanche is a 1991 model year. So what I'm about to show you will actually apply to a lot of other Dodge, Chrysler, Jeep products of the era. And being a 91, it's not OBD2 compatible, so I don't have a port to plug into to check for codes. But over in the panel here, there's a check engine light, and if you turn the key on, off, and on again without starting the vehicle, it'll flash the check engine light, so I'll show you that. So basically you count the flashes of the check engine light to determine your code, and I'll just talk over it, but it's going to flash a code 12, and then a code 21, and then a code 55. And the code 12 just indicates that the battery's been disconnected recently. The code 55 means it's the end of codes, and the code 21 refers to an O2 sensor problem. Okay, so I actually happen to have the Jeep 91 shop manual that the dealerships would have used back in the day, and so we'll just turn to that section, and we can see here code 21, O2 signal stays at center, or O2 signal shorted to voltage. Neither rich nor lean condition is detected from the oxygen sensor input. Oxygen sensor input voltage maintained above normal operating range. Now this is back in the day when you didn't have hundreds of trouble codes. You know, like I say, OBD2 or newer, it's a lot easier to do diagnosis, and the codes can be more specific. There is only a couple other O2 codes that the signal is staying below center lean or staying above center rich. I don't have those, but near as I can tell, it's the only, it seems to be kind of a general O2 sensor signal code. So I was editing the video and I noticed that the flashes were not exactly what I was telling you, so I just want to demonstrate again really quick here the actual flashes so you can see. I'll count them out. One, 2, so that's the code 12. 1, 2, 3, 4, 5. So that'll be code 15. 1, 2, 1. So there's the code 21. Okay, so as you saw there was the code 12, which we can safely ignore. There was a new code, which is 15, and then there was the code 21 that I mentioned, and then the 55, which means end of codes. So if we take a look at the booklet, the code 15 is no vehicle speed signal, no distance sensor signal detected during road load conditions, and that's a good catch because the speedometer does work intermittently. And I think I have a good idea of what's causing that. So I'm going to look at that too when I'm underneath, but that won't be part of this video. But yeah, I just caught when I was editing the video that I was like, wait a minute, those flashes aren't quite matching up to what I got the other day. And that's why. I guess I should add one more thing, that there is a diagnostic scanner that you can buy that dealerships would have used back in the day. And I don't know if you'd be able to find one. Maybe you'd find one used on eBay or something, but there technically is a diagnostic port, but it's not traditional. Like, it's not like your OBD2 port. It's kind of a special one. All right, so let's go under here, and actually the first step should be to visually, well, first identify the O2 sensor. So there it is. It looks like it's probably original, but we really want to pay attention to the wiring and the connector. Now I can't actually reach it from where I am, but I'll change position in a minute, but just to show you. So I can see that doesn't appear to be any breaks or cuts or damage here from the sensor back to the connector. So in your case, like especially if you have four-wheel drive, you'll have another drive shaft here in the way and stuff. So just be aware that, you know, visual inspection is the first thing. So I'm just going to change position, and then I'll show you how to actually test the sensor. I'm not sure how well you can see this, but basically what I'm going to try to do is disconnect the electrical connector from this other connector here. Alright, so I got the O2 sensor connector disconnected here. Now you can see there's four wires. There's a black wire. Let's see if I can move you up a little better. So there's a black wire, a white wire, two white wires, and a gray wire. So what you need to know is the two white wires are for the heater, because it's a heated oxygen sensor. And so what happens is voltage is applied down those two wires to heat up the sensor to lower emissions sooner after startup. So there's two tests we can do. One is to test that heater circuit, and all you need to do is get the digital volt ohm meter. Let me get mine ready here. So get your digital volt ohm meter and set it to the ohms position. And let's see if I can just kind of set it there. And then I'll probe these two white wires in the connector directly. Hopefully you can see this. There we go. Finally got it. So it's 6.6 ohms, 6.5. So in order for the heater circuit to be operating correctly, it needs to be between 5 and 7 ohms. And like I say, that should apply generally speaking to at least similar models to this one. So 6.4, that's well within spec. So the next thing we need to do is test the, let me set that down. We need to test the signal on the black and gray wires. So I'll just get repositioned, then I'll show you how I'm going to do that. Okay, so now I have the luxury of owning these wire piercing devices. So if you don't have these, you could use a pin, or you could back probe the connector using paper clips or something. But how these work is, as I tighten it down at this end, this comes down and kind of grips the wire and then pierces it. It's really hard to see the details, but I just turn this end and that tightens it down. So I'm going to hook it up on the other wire here. I already hooked up one. So again, we just need to hook up to the black and the gray this time. Okay, now so I have those two wires tapped into, and I have this other connector which just has two wire leads, and it's just an extension. So all I'm going to do is run this extension back to the cab. So let's connect these up. There. This is connected securely enough that I could go for a drive. And now we'll take the multimeter back into the cab and we'll hook onto the other end of this. Okay, so I'll just give you a quick overview of what I've done. So I connected into those two wires so I could watch the signal while the engine's running. So if I come up here, you can see I just simply routed this extension cable for the wiring. Just literally out the corner of the hood, side the door, just across the dash. And then I connected this connector up to my multimeter, and I have it set on the lower of the DC volts here. What we're going to be watching for is the O2 sensor to be switching between 0 and 1 volts as it's trying to correct the air-fuel ratio. So I'll switch out here and then we'll go for a little drive. Alright, so I'm going to start up the truck and go for a short drive. And what we're looking for, once the engine is warmed up especially, because for the first minute or two the truck might be in closed loop mode, or pardon me, open loop mode, and then it needs to go into closed loop for emissions. And really what that means is for the first minute or two the O2 sensor signal is oftentimes ignored anyway. But what we're going to be looking for is that number to fluctuate between 0 and 1 volts at a fairly rapid pace. So we can safely ignore this for a minute or so, minute or two. Let's go for a drive. The number's climbing, but it's not actually going up and down yet. So. Yeah, there we can see it switching. Surprised it's switching that fast, that early. So far, that's what we want to see. We want to see, generally speaking, probably 0.2 to 0.8 volts up and down, kind of continuously. Really what you're watching for is you don't want that number to like really stick at any one number. You want it to be changing pretty much constantly. Well, I just went for about a 10-minute drive, and you know what, the engine's actually running a little smoother, and the sensor's responding like it should. When I did this the other day, what was happening was that value was sticking for like 15-20 seconds. Like it would stick at like 0.17 or like 0.85, and so clearly whatever the issue is intermittent. Maybe taking apart that connector had something to do with it again, but it's also a pretty warm day today, so maybe it's something that'll be more apparent when it's cooler. So what I'll do is I'll just leave this hooked up, and then tomorrow morning when the truck's cooler and has been sitting overnight, I will try this again and see maybe this is temperature related. Alright, well, it's the next morning, and truck's been sitting all night. It's not real cold today. It's plus 13 degrees Celsius right now, but let's do this again and see if I can get this to duplicate the issue. There we go. I think it just stuck at 0.17. Yes, I was able to duplicate it. There we go. I'm varying my speed a bit, and it's sticking. So I am happy about that. So you can see here, like I mentioned before, the O2 sensor signal sticks. The engine was actually running 100% normal up until that point. So that's good news. I was able to duplicate the issue. I ordered up a new sensor from Rock Auto just because it was quite a bit cheaper than buying it locally, and I'll probably wind up selling the truck soon, so I didn't want to put a whole lot of cash in. See, and there, let's see what happens. Yeah, so it come back up to 0.85, 0.86. I bet you it's going to stick around there. Let's see. No. Well, you can see there that I was able to actually duplicate it, so that's great. You can see that's really what you're looking for, is you're looking for the signal to stick or be above or out of range, like, you know, if it's at 0 or it's at 1, or if it sticks there, there's something wrong. Anyway, so I'll get that new sensor in, should be here in a few days, and we'll continue the video. All right, well, I have the new sensor here. It's actually been over a month since I ordered it. There's a little delay here. So this is the sensor. I purchased the brand is NTK, which is owned by the company NGK. So the part number is 23023. I'll put a link in the description below so you can find it on Amazon. So anyway, so here's the sensor. The reason I went with NTK is because they make the OEM Jeep sensor. So the one that came in this truck from the factory would be NTK brand. Anyway, so you can see it's visually identical to the factory, the one that's in there, same wiring colors, little cover on the wiring harness. The connector appears to be identical. It even has the little clip here. Yeah, so what you need to know about the new sensor is that this is just a plastic protective cap that's on here. And if you take note, there's kind of a dark area. What that is there's anti-seize compound on the threads. So if I pull this back, you can see here's the threads that are going to screw into the exhaust. And there's a crush washer here. And this is just a protective cover. So I'm going to keep that down until I actually go to install it. So you can actually get special sockets and other, like, there's a couple different styles of sockets to remove these. I don't have that socket, so I'm just going to try to use a 22mm wrench. 7/8 wrench would also work. If for some reason this isn't working, I know a buddy that has the right sockets. So if you're buying a sensor, I definitely recommend you stick with one like this that has the right connector versus the one that might just have, say, 4 wires coming out of it, and you need to cut the old wiring and solder them, or, you know, connect them, because this is designed for this application. So the sensitivity on it will be correct versus a universal one might not be as good in the long run. All right, so just a couple other tips here before I go. I know the video is getting long, sorry about that. So one more thing you'll want to do regarding the electrical connections is you'll want to put some electrical grease on there. Now I know a lot of people are just going to go and grab dielectric grease. It's technically not the right product. This is also dielectric compound, but what you want to get is electrical grease. This one I got, I think I got this off of Amazon. I'll put a link in the description below, but this is specifically for like lower voltage applications, and also it's safe to use on terminals. Whereas if you look at the dielectric compound, it says for ignition wires, coat the entire interior surface of boots before installing, and for high voltage circuits only, not for use in electrical connectors. Now, I don't know why. You can go into any parts store and you can find dielectric grease. They're going to have lots of it. It's going to be hard to find electrical grease. But this is really what you should be using. Dielectric grease. Generally, you shouldn't even really be putting it on electrical terminals. So the only other couple things I want to mention is that I will disconnect the battery to reset the codes, to clear the codes. And the other thing is that the torque value for tightening this down is 23 foot-pounds. So I'm not going to show you, this is kind of simple. You just unscrew the old one, disconnect the connector, and reinstall the new one, tighten it down. So I'm not going to show you that. This video is more about the diagnostics and just kind of showing you what you need to know, what you need to do to diagnose. A lot of people are just going to be like, okay, well, I have an O2 sensor problem, and they're just going to buy a new O2 sensor. Well, I like to go through that whole diagnostic process so that I'm not wasting money or time. So anyway, I hope you liked the video, even though I know it did get a bit long. If you like the video, please give it a thumbs up, because that helps YouTubers out. And if you have any comments, leave them below. Maybe you've had this problem, or you have a question that I didn't answer here. So thanks for watching.